When we look up at a deep space field like this one, packed with countless distant galaxies, the cosmos feels vast, ancient, and entirely eternal. Our brains are biologically wired to expect that stability. Every sight you process, every sound you hear, and every physical interaction you have relies on the assumption that the ground beneath your feet and the sky above your head are permanent fixtures of reality. But the laws of physics dictate otherwise. The solid, dependable universe we perceive is an illusion, and it is entirely temporary. The cosmos has a guaranteed expiration date. The only unknown is exactly how the destruction will happen, and that comes down to which physical law reaches its breaking point first. By examining the forces holding reality together, from the massive scale of astrophysics down to the invisible realm of subatomic particles, we find that our existence is far more fragile than our senses suggest. This diagram shows the trajectory of the universe on the grandest cosmic scale, where every galaxy is locked in a relentless tug-of-war. On one end is the inward pull of gravity, on the other, the outward push of cosmic expansion. If gravity ultimately wins, we get the big crunch. The outward momentum of the cosmos halts, reverses, and accelerates inward, eventually crushing the universe back down into an infinitely dense, superheated point. Current data, however, shows that expansion is winning. This leads to the big freeze. Space stretches outward so violently that galaxies are accelerated away from one another forever, permanently isolated in the dark. Once those galaxies drift apart, the fuel required to form new stars runs out. Existing stars will slowly die, leaving behind only supermassive black holes. And as physicist Stephen Hawking proved, even those black holes will eventually evaporate away, leaking their mass into the void as thermal radiation. What remains is a state of absolute zero energy. There is no light, no sound, and no movement. The cosmic battery is completely drained. If astrophysics dictates our end, this fiery, dynamic universe is destined for a painfully slow, inescapable freezing silence. A big freeze would take trillions of years to unfold. But zooming down to the subatomic level reveals a mechanism capable of ending reality in a fraction of a second. It all revolves around the Higgs field. Physicist Peter Higgs helped discover that this invisible energy field permeates all of space, interacting with particles and giving mass to everything in the universe. This graph illustrates the energy state of that field. Currently, our universe rests right here, in a small dip halfway down the slope, known as a false vacuum. It appears stable, but it hasn't actually reached its true lowest possible energy state at the bottom. If the field experiences the right quantum disruption, it could slip out of this temporary state. When it plunges to the bottom, it triggers a catastrophic shift in reality. This is false vacuum decay. A bubble of pure destruction expands outward at the speed of light, instantly altering the fundamental laws of physics and erasing everything it touches without a single moment of warning. While the cosmic freeze is agonizingly slow, this subatomic mechanism proves that our physical reality is a highly volatile house of cards, capable of collapsing at any moment. Yet there is a third scenario. If we move past physical matter entirely and look at the foundation of quantum mechanics, we hit the bizarre logic of observation. Experiments like the double slit test suggest that at the lowest levels of reality, physical matter exists merely as probabilities. Those particles only resolve into a definite solid state when they are actively observed and measured. The human brain functions as an interpreter for this process. It takes incredibly limited sensory inputs, like scattered light waves and sound frequencies, and stitches them together to project a coherent, three-dimensional physical reality in your mind. This presents a deeply unnerving existential theory. If reality functions essentially like a computer game, only rendering the physics and pixels that are actively being looked at, what happens to the universe when all conscious observers die? The most absolute end to the universe might not be a physical explosion or a thermodynamic freeze. It might simply be a quantum unrendering, the exact moment the simulation loses its audience and powers down. Between the crushing forces of cosmic expansion, the precarious balance of subatomic decay, and the strange requirements of quantum observation, the universe is clearly not a permanent fixture. But this inevitable doom doesn't have to be a source of dread. The absolute certainty of the universe's destruction is exactly what makes our current reality so deeply valuable. We exist in the cosmic Goldilocks era. It is a highly improbable, temporary window of time where chemistry functions smoothly, stars shine intensely, and the exact conditions necessary for life to thrive are actually present. It took billions of years for the universe to produce the human brain, a structure possessing the precise capabilities needed to wake up, look around, and witness the cosmos before it's gone. The universe will absolutely be destroyed, but the staggering mathematical improbability of being alive right now to observe it makes this brief, beautiful illusion the most precious thing in reality.